Hi, I'm following along with Paul McWhorter's Raspberry Pi lessons. When the lessons started, Raspberry Pi 3s, 4s and 400s were hard to find, very expensive. Even though I had a Pi 4, I decided to see if I could do the lessons on a Pico. I had never even done more than take it out of the box before, but I thought that the logic of the program would be the same, it's just the syntax would be different. I managed to do the lessons on the Pi 4 and the Pico, but then I was in a bit of a quandary. If I amended the logic of the Pi 4, should I then change the syntax to run on the Pico, or should I change the logic of the first Pico program? Either way, I'll be wasting a lot of time and effort. I thought that there must be a better way. Why not write a program that could run on both the Pi 4 and the Pico? I only thought of this a couple of days ago after watching Paul's live talk announcing that his Pico classes would be starting in January. Hopefully some of you guys will find it useful. My apologies, I'm really not very good at making videos, but I'd be very grateful if you could leave a comment saying how I could do better and how soon you gave up watching it. Now this is my setup. The left hand window is Thonny, which is running on my Raspberry Pi 4, and I've connected to it by using VNC. Then the middle window is Putty, which is also connected to my Pi 4, and my camera is showing that really I ought to clear up my desk a bit more often. And the right hand window is Thonny, which is running on my PC connected to my Pico. Right, first of all you need to find out what version of Python you're running. So if you go over to the left hand window and you type import sys and then print sys.version and save that as demo1.py. And you run that, and as one would expect, we're running Python 3.7.3. Right. Now we go over to the Pico and do the same thing. Import, sys print sys.version, save that as demo1.py, and we'll run that. That comes up with something more interesting. It actually says MicroPython. So now that seems to be a good idea to find out how what you're running. So we'll go back to the Python, the Pi, and here we will put if MicroPython, I spelled that right? Yep. In sys.version, I will say using Pico equals true, else using Pico equals false. And then I will say using Pi equals not using Pico. Now the reason why I've done that is it's so much easier to go if using Pico or if using Pi, as opposed to saying if not using Pico. Right, then I've got the Princess, just to see if it's working, Princess version, and then print using Pico. And we can copy that line, whoops, and change it to using Pico and using Pico. Right, we'll run that and see what happens. Ah, good. We're still on Python 3.7.3, and using Pico is false, which is good because we aren't. Using Pi is true, which is good because we are. Right, now we want to run the same program on the Pico version in Thonny. So we will copy all those lines, go over here, delete those, and then paste. And it doesn't work. And you think, oh, that's not fair. I'm trying to, I'm copying lines from Thonny into Thonny and it doesn't work. So the way around it is to go into your putty window and you go cat demo1.py. Yep. Then you can copy all of those lines like that. Put them in there. Run it. And what happens? Yep, you're still using MicroPython. Pico, using Pico true, using Pi false. Great. Great. So far, so good. Now you go back to your Pi version and you want to add a couple of lines to help you see what's going on. So if you put in a comment here going, here is where you put the imports for Pi and Pico. Copy that line, paste it there, paste it there. Right, if MicroPython, here is where you put the imports for Pico, and that isn't MicroPy, so it's here's where you put the imports for Pi. So far so good. And then you don't want any of those print statements. May as well save that just in case something horrendous happens. Oh, didn't want to save as. Oh, come on. Cancel. Right. File. Save. That's better. Right. We'll start another program and we will save it as demo2.py. And in demo2 we will copy all of the lines from demo1, copy and paste. Now I've got a very simple program that is just blinking an LED on and off for a certain number of times. So first of all, I think if we run it, then we'll see what it does. Run it. This is running on my Pi 4, which is here. How many times do you want to blink? 3. Hurrah! It's working! It's working, it's working, it's working. That's good. Right, we will now take all the lines from Blink, copy them and put them into demo 2. Now we go up a bit. Excuse me. Now, from time import sleep, that we want to do that for the Pico and the Pi, so we put that up there where it says Now, import rpi GPIO. Now that is definitely for when you're using the Pi, so we take that one out and we'll put it in there. Remembering to indent there. Now, if we look down, we want to replace all of the lines that are specific to the Pi and replace them with the function. So if we put in a function called setup, and then up here we define the function setup, and we just take those two lines and put them in there. That ought to be equivalent. Now that line is specifically for the Pi, so again, oh, but the indentation's wrong. There, that looks better. Now instead of the GPIO.output, we go turn LED on, and up here we define a function turn LED on, and in it we put that line. Right, we'll go down a bit further. We want to do the same thing for that the red false thingy. Right, so here we go turn LED off, whoops, off, and up here we define a function that is turn LED off, and we put that line in there, X, and paste. Now we go down to the bottom, just GPIO cleanup. Now here we will just go clean up, and up here we'll define the function for cleanup, def clean up, and we'll just put that line in there. Indentation's wrong. Right, we'll just have a quick look. That looks okay. Set up, turn LED on, turn. Right, we'll try running it to see if we've broken it. How many times do you want to blink? 4. Oops. No. Turn LED off. Right. Where's that? Turn LED off. Turn LED off. Right. Try and run it again. How many times do you want to blink? Oh, I've got that warning because of course I got an error when I hadn't cleaned up the GPIO pins. How many times do you want to blink? 4. And it's blinking. Right, that's good. So I haven't broken anything, luckily. Now, we want to look at the code again. Now, with the setup, we only actually want to do the GPIO setup if you're running on the Pi. So you put if using pi colon, and then get the alignment right, copy that line, go down, paste, tab, paste, tab, paste, tab. Right, we'll go down. Right, nothing else needs to be changed. We'll try running again to see if we've broken it. How many times do you want to blink? Whoops. 3. So far, so good. Now we want to, she says, looking for a bit of paper. Now we want to put in the functionality for the Pico. So we go back up to the top. Right, we've got the import for the pi, we want the import for the Pico. So here we have to put get our alignment right, tab, from machine import pin, and then that needs to be tabbed in. Right, then we have to change all the functionality of the other things. So the setup, we go if using Pico colon, and we have to find the format for how to set up on the Pico, which I happen to know, which is pin, open bracket, red, comma, pin dot out. That's all you need for that one. And then we'll copy those 2 lines and we'll go down to here, paste them in. If using Pico, you want pin red, value equals true. Go down a bit further, copy those 2 lines, copy, paste, value equals false, to turn it off. Now clean up, you don't need to clean up the pins in on the Pico, but if you put that in a try and accept, or you press stop while it was running, you'd want to make sure that the LED was actually off. So we copy those 2 lines and put them in there. We'll just go down and have a look. That all seems okay. Right, we'll try running it to see if we've broken anything. How many times do you want to blink? Well, we don't really want to blink at all. 2. Hurrah! Right, it doesn't appear as if I've broken anything. So now we need to copy it over to the Pico. So we will go clear, and then we will go cat demo 2. We will copy all those lines copy, go over to Pico, open a new file, save it as demo2.py, copy all the lines in, and we'll see what happens. Now on the Pico, I'm actually using the built-in LED, which is there, which is pin number 25. So you mustn't forget that you have to change the pin number. So down here, I will change it to 25. Fingers crossed. How many times do you want to blink? 4. Oh, press that enter. And look, it's blinking. So I've managed to write a program where you can have all the functionality for the Pico and it doesn't interfere with the Pi and vice versa. So that is quite amazing. Now we want to try another program because blinking LEDs is all very well, but it's a bit boring. So we go back on to the Raspberry Pi version. We will create another program which is cunningly called, save as, cunningly called demo3.py, and I've got a program on here that is just setting up a chip with a potentiometer and printing out the results. So we'll try running it to see if it works. Right, it's doing something. So you twiddle the thing. It's going up, it's going up, it's going up. Right, it goes down again. Hurrah, that appears to be working. Right, stop that. So we will, from demo 1, we will take all those lines, copy, put them into demo 3, paste. Then we will go into anin, and we won't bother with those 2 lines. We'll take all those lines, copy, and paste them in there. Right, now we have to work out where to put everything. Here's where you put the imports of Pi and Pico. Right, so you take from time, take that and put it there. Import ADC0834. Yeah, okay, that is definitely for the Pi. So we'll stick it in there, and you have to indent it. Now, all you do now is chip setup and chip get result. Right, so you need to define a function which we can call setup. I deliberately spell it differently from how normal things are spelt, because then I know the difference between my functions and other people's functions. Right, and all that needs in there is chip setup, and then in the actual program we just want to go set up, and then we want to do something with this print chip get result. So you want to do another function, def read pot. That should do it, colon, and then we just want to return the value, it's red, which is chip dot get result from channel 0. then that print actually wants to be the function. So let's read pot. Now we could live dangerously and add a couple of lines. In the setup, we only want to do that if we're using pi, so we can go if using pi chip setup. Oh, that setup was in the wrong place. Good thing I spotted that. There. Wants to go there. And it isn't indented. Right. There we go. And here the same, if using pi, that's what we want to return that. Paste. And that wants to be indented. Right. We haven't changed any logic at all, really. We've just put it into functions. Right. Fingers crossed. Try and run it. Oh, oh no. Oh no. No. Something terrible's happened. What have I done? Set up. I'm returning read pot, which is a function. I want the value. Right, if we just put in that and that. Oh, try again. Aha, it's given me a number. Turn it up. Yep. Turn it down. Right. I haven't broken anything yet. Now, we want to put in functionality for the Pico now. Right, so that's for both. It's here that you want to put it in, and you go, I've lost my indentation again. Then you go from machine import ADC, all in capitals. That's all you need there. And then you go to the setup, if you can get down there. Right, you want to put if using Pico, you want the equivalent to chip setup, which actually happens to be ADC 26, because I'm using pin 26 for that. It's one of the ones that's reserved for ADC. And then you just need to, in the read pot thing, you need to do the same again. If using Pico, you go ADC 26 dot read underscore U16. Is that it? No, I want to return that value. I don't just want to do it. Right. Now, that all looks, just have a quick check. Import. Set it up. Read the pot. While true, print that. Right. We'll try running it again. Well, by putting in all the Pico stuff, I haven't broken the Pi version. So we'll stop that. Then we'll go over to the putty, because now we want to copy everything over to the Pico. So we'll go clear to make everything look a bit easier. and then cat demo, this time it's demo 3, and we copy all of those lines, copy, we go over to the Pico, we will save that as demo3.py, put in all the lines, and we'll just try and run it. Oh, there's a number. There's definitely a number there. Right, we will try and see. Aha! Look at that. It goes up to the maximum number for an unsigned 16-bit integer. And there. So once again, the Pico and the Pi versions can kind of coexist very nicely. Right, if there's anyone still watching, you're probably wondering, this is an awful lot of trouble to go to for such simple programs, but it is just to demonstrate that you can do it. So I mean, you can pass parameters into the functions if you wanted. So if you wanted to turn an LED on, you could actually pass the pin number to it, so you wouldn't have to define a function for every line. And I'm going to start including this in all my Python programs from now on, because you can write the programs with this outside bit on it, and it means that if ever you did want to run it on your Pico, or if you write it on the Pico and you wanted to run the Pi, then it would be okay. I apologise for the bad video, but I hope you like the program. Okay.